There's a small kind of trouble that many people who use cordless tools eventually run into. One day you reach for the drill like you always do, expecting it to start right up, and suddenly the spare battery refuses to cooperate. No warning, no dramatic moment, just silence. It's the sort of problem that arrives quietly and leaves you wondering what just happened. From the outside, a backup battery looks like a simple block of plastic. But inside it's actually a carefully built system. Beneath that shell are several lithium-ion cells connected together to store and deliver energy in a stable way. Along with those cells sits a small electronic circuit board, often called the battery management system. Its job is to monitor voltage, control charging and discharging, and protect the battery from conditions that might damage it. Because of that protection system, some very common situations can cause the battery to stop responding. One of the most typical causes is charging the battery for far too long without unplugging it, even after it is already full. Over time, this can put stress on the protection system and trigger a shutdown. The opposite situation can lead to a similar result. When a lithium battery is left completely drained for a long time without being recharged, the internal voltage may drop below a safe level. When that happens, the protection circuit may lock the battery entirely. This is why the situation often feels confusing. Nothing looks damaged from the outside, yet the battery suddenly seems lifeless. When this happens, many people start experimenting without really understanding the cause, while others immediately spend money sending it out for repair. But in many cases, the real issue is simply a lack of understanding about how the battery works. And once that becomes clear, a problem that once seemed mysterious starts to make much more sense. Before attempting to restore the spare battery, I'll begin by cleaning the inside of the battery pack first. Dust, moisture, or small bits of debris can sometimes collect inside over time, and giving the interior a quick inspection and cleaning is always a sensible first step. But before even thinking about opening the outer casing, there is one important thing everyone should keep in mind. Always check whether the battery still has any remaining charge. Even when a battery seems completely unresponsive from the outside, it may still contain stored energy inside. That's why a little caution goes a long way. Taking a moment to confirm the battery's condition before removing the outer shell can help avoid unnecessary risks and make the process much safer. For batteries that have been used for a long time or often operate in dusty environments, it's not unusual to find dust inside the spare battery pack. In some cases, there may even be small traces of rust on important metal components, something that the naked eye might not immediately notice. To achieve the best cleaning results, using a multi-purpose oil like WD-40 is a practical and reliable choice. This type of oil is designed to loosen light rust, push away moisture, and help clean metal surfaces without requiring complicated tools or chemicals. When applied carefully, it can help remove fine dust, oxidation, and early signs of corrosion that may form on important metal contacts or connectors inside the battery pack. Another advantage of a multi-purpose oil is that it leaves behind a thin protective layer. This layer helps reduce future moisture buildup and slows down the formation of rust on exposed metal parts. In environments where tools are frequently exposed to humidity or dust, this small step can make a noticeable difference in maintaining the condition of the internal components. Because of these properties, WD-40 is often considered a sensible option when dealing with light corrosion or dirty electrical contact points. It allows the cleaning process to be done more effectively while helping protect the metal parts that play an important role in delivering stable electrical connections. After drying the spare battery with the heat gun, the next step is to move on to addressing the battery issue. To continue the process, I'll make a simple power activation tool using an old phone charger that still works properly. These chargers are quite convenient for small DIY electrical tasks because they provide a stable and moderate power output, which is often sufficient for basic testing or for gently supplying power to electronic components. Instead of using complicated equipment, repurposing a phone charger can be a practical solution. Most chargers are designed to deliver a steady voltage and a modest amount of current, which makes them suitable for light electrical work. As long as the charger is still functioning well, it can serve as a reliable power source for a simple homemade tool. Using something that is already available not only saves time and cost, but also shows how everyday electronic items can still be useful in small repair or troubleshooting situations. Here I have 2 alligator clips. These small metal clips are very common in electrical work because they make temporary connections quick and convenient. Each clip has a spring-loaded jaw with sharp metal teeth that can grip onto wires, terminals, or metal contact points without needing to hold them by hand. Thanks to that simple design, alligator clips are often used in testing, charging, or short-term power connections. They allow electricity to pass through the clip while keeping the connection steady and secure. In many DIY projects or small repair tasks, they are extremely useful because they save time and make it easier to connect and disconnect components whenever needed. Even though they look simple, these clips play an important role whenever a quick and reliable electrical connection is required. I have one small note to keep in mind. About every 15 seconds, it's a good idea to check the battery once to see how things are progressing. Continue doing this until the issue is resolved. Regular checks like this help prevent the battery from being exposed to power for too long, which could negatively affect the cells inside the battery pack. Looks like that should do the trick. Now I'll take the battery and put it back on the charger to see how it performs. The battery is fully charged now. The next step is to test it in real conditions to see whether it works steadily. After that, I'll be able to make a more accurate conclusion about its condition. So we've done it successfully. The spare battery is working again just like it should. Sometimes a problem that seems complicated at first simply needs a little understanding and patience to solve.